Hello, good morning, good afternoon, good evening, wherever you are. Welcome back to Streaming Media Connect 2025. I'm Steve Nathans Kelly, Editor-in-Chief of Streaming Media and Chair of Streaming Media Connect. And you have joined our second session of the week, which is Beat the Clock, How to Deliver 5/9 Sports Streams at Scale, brought to you by the good folks at EZDRM. Before we get started, I've just got a couple of housekeeping announcements. Um, we are doing our familiar Name That Tune thing. So you heard the music that we were playing coming in here, and the first person to identify the track and the artist will win a $50 gift card at the end of the session. But you must be present at the end of the session to win. As we go into the discussion here, feel free to chat amongst yourselves in the chat, but we will be taking Q&A at the end of the session, so put your questions for the panel in the Q&A, and we'll get to as many as we can at the end of the discussion. Sessions from all 3 days of the conference this week will appear on our YouTube channel, on the Streaming Media YouTube channel, and the link for that will be in the chat. And we'll be back here May 20th to 22nd for our next Streaming Media Connect event, and the call for speakers is open now. The link for that should be in the chat too. It'll say February, but if you put in your speaking proposal in there, I will see it, and it'll go into the hopper for the next one. Without further ado, I would like to welcome Jason Thibeault to the stage from the SVTA. Welcome, JT.
Hey, Steve. Thanks for the introduction.
Yeah.
Hey, everybody. I'm JT. I'm the CEO of the SVTA. And this is a great panel. Like, really excited about talking about this topic with the panelists that we have. So I'm the CEO of the Streaming Video Technology Alliance, and let's spend a little bit of time getting to know our panelists, and then we'll jump into the conversation. So let's start out with Sean. Tell us a little bit about yourself.
Hey, thanks, JT. Sean McCarthy. I am currently at YouTube working on the live OTT platform. So all of the platform that powers YouTube TV, primetime channels, essentially any premium live content. And obviously, we're heavily involved in sports streaming and really large scale streaming, and as well as chairing the QoE working group at the SVTA that JT is leading. So happy to be here.
Fantastic. Thanks. Tom.
Thanks, JT. Thanks for having me. I'm Tom Buffolano. I'm head of business development for sports, and with a focus on college sports at the Switch, and recently acquired, or about a year and a half ago, acquired by Tata Communications. Now we're part of the Tata Media and Entertainment Services group, and I'm involved in a lot of stuff in terms of content acquisition and distribution and monetization. So happy to be here.
Fantastic. Christy.
Hi, everybody. Christy Tanner. I've been in streaming TV for 2 decades. Right now, I'm chairing the launch of Swerve Sports, which will be a new streaming channel focused on women's sports. And my company, Swerve TV, also runs the leading combat sports channel, which is called Swerve Combat.
Awesome. Excellent. Will.
Hey, everyone. A pleasure to be here. Thanks, JT. My name is Will Law. I'm Chief Architect in the Cloud Technology Group at Akamai. Akamai, you probably know us as a CDN, although the reality today is more than half our revenue now comes from security services. And we've also entered into cloud compute. So we're delivery, cloud compute, and security. I'm active outside the company in the industry, especially from a Dash Industry Forum, worked with them for a long time. CTA Wave, I edit and chair the CMCD working group, also CMSD. At W3C, I chair the Web Transport Working Group, and I'm involved at IETF and Media Over Quick right now, and also SVTA. We just recently joined in the QoE working group as well. So pleasure to be here.
Crazy busy guy. And last but definitely not least is Olga.
Hi, everybody. Thank you for joining us. And JT, thank you for running this panel. My name is Olga Kornienko. I am the CEO and co-founder of EZDRM. We have been in the industry securing content for, over 20 years. And we've recently also gotten involved with C2PA, which is a organization that looks at provenance of content. And overall, we've been actively looking at what we can do with the piracy, or, to help the anti-piracy within our media, and especially in live sports and whatnot. And I've known Will through Dash IF and most everybody here for quite some time. We're also members of SVTA. So thank you for having us.
Fantastic. All right. So let's start out with something kind of high level, just, get our bearings a bit. Obviously, we're seeing a lot of big sporting events. A lot of stuff is happening. Live sports seem to be the place where content is really hot right now. So maybe, Christy, maybe you can start us off with this one. But where are we seeing some of the big challenges of streaming high quality live sports at scale? I mean, what are maybe some of the common pitfalls of failure?
Well, let's start with the definition of scale, which might seem boring, but scale is the Olympics, is the Super Bowl, is the Mike Tyson, Jake Paul fight. Those are the massive, massive events. Those are different from the 150 live events we've streamed on Swerve in the past year, or a weekly or NFL game or more. And I think that distinguishes where the challenges are, because things that you're doing all the time, you can develop a routine, you can work out the kinks if you're doing them frequently enough. But when you have an Olympics or a Super Bowl that occur less frequently, what happens is that consumer habits change, technology changes, and it's really, I think, legitimately very challenging for those who are trying to stream at scale to manage all the potential pitfalls.
Anybody else? What are some thoughts in here? This is a greenfield question.
Right. I'll jump in. So scale to me, Christy, that was a great opening, by the way. Scale to me is 400 colleges, athletic departments streaming, 150 events each to ESPN Plus. So, that's a huge part of, the Disney bundle now. But that, how do you, and again, I lived this a little bit when I was, or not as great of a scale, when I was at, I developed college sports television and then ultimately CBS Sports All Access. And what I ran into there was things like customer authentication, because we did subscription as well, or piracy. How do you deal with piracy? Or first mile contribution to our platform from a university where maybe the bandwidth isn't all that great in order to support high quality stream. And then ultimately distribution, using a CDN that pushes content to the edge so that somebody in the middle of North Dakota can make sure that they get a Florida State football game, in a way that gives them high quality and ultimately where they're not a half an hour behind in terms of game time. So those are the things that I look at.
I'd add, I think Tom and Christy raise a good point. There's kind of two aspects of scale that I really think about. It used to always be on the delivery side. So thinking about large scale, delivery to large audiences, having, delivered 2 Super Bowls at CBS, there's definitely a lot of challenges. I'd say the first thing that comes to mind is preparation and the difficulty of load testing real viewing, real viewing patterns of behavior. It's not something you can really codify and load test, which makes, planning that much more important. But now, there's the same sort of delivery challenges, but because of the sort of MVPD style high channel count of linear channels at YouTube TV, I'm seeing a real big scaling challenge on the ingestion side. Being able to monitor, multiple copies of 6,000 plus linear channels, some of which have, direct fiber contribution. Others are coming over the internet through various protocols, some in low bandwidth situations like Tom mentioned, is a major challenge. And kind of modernizing that whole ingestion architecture is a big point of focus, making it more scalable, so that, we can scale to another 6,000 live events or linear channels and really not have to think about it. like the CDN sort of scales.
Well, I think that I would also add to that, Sean, or I'm sorry, Christy mentioned delivering worldwide. Devices are not the same worldwide. So when you're trying, I mean, I'm looking at it from a security perspective oftentimes, delivering from a security perspective to the array of devices that you find all over the world. If you think about large worldwide sporting events, trying to figure out how you deliver it securely, but also make sure that people who need to watch it can watch it. And what do you do with a collection of devices that might be jailbroken, might be supporting the latest stuff, or completely no security at all? Where do you draw the line, and how do you determine who gets to view the content and who completely doesn't, even if they're entitled to it?
Yeah, we see scale in terms of delivery traffic, right? And sports events today, when we talk about scale, are in tens of terabits per second. And we used to go back to when a terabit was the entire output of a CDN. Like that's probably a decade ago or so, right? And now we're doing tens of terabits. And the challenge with sports events is they're incredibly peaky. People join a football game, all join, say, in the first 5 to 10 minutes. So you have no traffic, and then within 10 minutes, you have 20 terabits. And this traffic has to come from somewhere. You can't simply put a bunch of centrally located servers and expect the traffic to magically flow to people's end users. There's a tremendous amount of mapping of the server capacity to the network capacity to reach end consumers. I don't think people appreciate the complexity and the amount of manual planning that goes into ensuring that even if I have servers that can output so much data, that they're not going to flood the network and cause congestion. And there are many autonomous ASs around the country, and you have to plan very carefully for this huge and dramatic rise in traffic and make sure you have the machines to serve it, and then you have the networks to deliver it.
And well, didn't you do Indian cricket where it was some ridiculous number of terabits per second?
Yes, well, it was high until
last
Netflix
year?
came along, right? But the interesting thing about Indian cricket is the absolute volume is not that high. The number of concurrent users was very high. I think 30, 40, I don't want to misquote the numbers. But most, I think 96% of people watching were on cellular networks, which is incredible, right? The complexity of delivering that much traffic. So hats off to the Indian cellulars industry. They are fantastic in supporting peak scale load, but there's a lot of planning that goes into IPL, and it's different from that in the US because of that high percentage of cellular and mobile traffic, even though the bit rate going to each device is relatively low by US standards.
But it's really interesting. So Christy brought up the first point, which was scale is different for different events. But with that said, even smaller events can still suffer from a lot of these points of failure that you have all talked about, right? So from Sean talking about ingest, and Olga talking about devices, and Will talking about just, capacity of the delivery network associated with the live event. It's crazy. There's lots of points of failure up and down the chain, regardless really of how big your event is. So scale, in a sense, could be somehow proportionally related to the amount of infrastructure you have to support it. So I'm curious about, I'm going to lead into this next question because, Will, you did bring up Netflix. So let's talk a little bit about Netflix. And I'm gonna caveat this, right? We're totally supposing, right? Because the only people who really know how the Tyson-Paul match had quality issues are the people that are within that ecosystem. And so I just want to say that as a caveat, but I want to talk about this because there were quality issues. People noticed it, they wrote about it, lots of people talked about it. So, maybe Will, maybe you can kick this off for us and everyone can jump in afterwards, but what might have been the problem here with the quality issues related to that event?
So I see a different story here, which I'm going to answer this, right? So everyone says, oh my God, there were 1 million people who had rebuffering issues, right? And this was talked about in the press and not. The story I see it is completely different. 59 million people didn't have rebuffering issues.
I like that.
That's huge. That's from a company that 2 years ago, I think March 23 was Netflix's first live event. So in 2 years, they've ramped up to deliver 59 million rebuffer-free sessions. That's fantastic. I think the issues that occurred, and it's not for us to say how or where they occurred. The engineering and Netflix Ninja team are very, very capable. They know those issues. They are not going to happen again, right? They are going to solve those, and new issues will open up, but they will diminish over time. They have a fantastic capability to deliver live traffic. They're doing it from a platform. They're vertically integrated. They control the player, the delivery network. They're doing all that network planning that I spoke about earlier. So I have a very different view. Seeing all the challenges that come with scale of that size, I thought they did very, very well. And I think it's a distraction to talk about some of the rebuffering that happened. If it happens for the next 3 live events, yes, that's a failure to solve problems. But I don't think Netflix are going to fail to solve those problems.
No, and it didn't with the Christmas football, right? It actually went very, very, very well. Different amount of concurrence and scale, but still very well, very well. So anybody, Christy, Sean, anybody, Tom, what are your thoughts?
Well, I think some of the unpredictability of the Tyson-Paul match originated with the social nature of Jake Paul's fan base. And so that is something that is really different from the NFL, which it is fairly predictable. Even if you haven't streamed an NFL game on Christmas before, it's a fairly predictable audience. Whereas the combat sports fan base and the social fan base that Jake Paul brings with him brought an element of unpredictability to that event that I think perhaps would have been very difficult for even the savviest streamer to prepare for, along with the idea that multiple devices in a household might be streaming at the same time, multiple devices from the same account. It brought with it a lot of pretty tricky aspects. And, I think the one last thing I'd say about it is that I don't think Netflix is held to similar standards as, for instance, a broadcaster streaming an event. So there is a little bit more wiggle room for them to experiment and take risks and fail.
Anybody want to add to that?
Yeah, I mean, I can't prognosticate about what actually went wrong, right? None of us know unless we were part of the engineering team. But to echo Will's sentiment that it's doing live at scale is really hard. Netflix does VOD at scale. YouTube does VOD and live at massive scale. But when you get these live events, it's a lot different, especially due to the peaky sort of bursty traffic patterns that alluded to earlier. I think a lot of this is related to capacity planning on the CDN side, but also partnerships with the ISPs, the big ASNs, the ones that have known congestion issues. At a certain point, a CDN can throw as many servers as they want at this, but if there's congestion at the peering points at the last mile ISPs, there's very little they can actually do. Netflix's topology is to build pretty deep into the ISPs, just like YouTube's. I think that's the way you're really going to scale live video, as more and more, especially even in the mobile networks, getting as close to the cell towers as possible. Is really how you're going to scale this to 50, 60, plus million viewers and deliver a high quality experience. It's one thing to throw multiple CDNs at the problem, which is, what a lot of the big broadcasters do. We did it Paramount Plus, and it's necessary, but I don't know if it's sufficient when you reach that sort of scale.
And three of you touched on. Oh, go ahead. Sorry.
So one of the approaches that we have at Tata is that we're sort of we're agnostic in terms of how we approach our distribution. So we'll use, and I think it was Olga or Christy who mentioned this in their write-up. We will use our own Tata CDN. We'll use AWS. We'll use whoever. We'll create the best sort of use case for our customer base, depending upon what they're trying to do geographically. So it's not just one CDN that can only give you, maybe it gives you 5 nines reliability, but we'll we'll assemble CDNs based upon where our customers are trying to deliver content to, so that the edge is as close to the consumer as possible. The other thing is, and Will mentioned this about cricket, I just got back from Kenya, and even though I could pick up, even though I had Wi-Fi in the middle of the Masai, the Masai Mara, I couldn't stream anything, right? But if you've got, events that people are trying to stream on mobile devices using cellular, that is a huge, huge challenge, especially if you're working on a global event.
Well, I think it's interesting. So you all brought up something that's really important. I think that we overlook sometimes in streaming is the relationship between the content owner and the delivery partners, whether those be the CDN or the ISP, right? And so Sean talked about peering points. And I think there was some discussion about that with the Netflix event, that some of the ISPs run their circuits and the peering points differently. They have them at 80% capacity, maybe instead of 40%. So they can't absorb a huge spike, which is what you talked about, which what Christy mentioned, right? Which is this massive thundering herd, and Will mentioned it. And so there's this real relationship that has to happen between these big content events and those ISPs and those independent ASs. I mean, it's really, really important. And I think, that's something that as an industry, we don't pay attention to as much because, for most of us, it's not important. It's really important for those capacity planners and those folks that are network engineers responsible for that. So one of the things, though, that's really kind of near and dear to my heart in a weird sort of way is something Olga mentioned at the beginning, which is devices, right? So we know that these events, when they go global, are going to markets where there are older devices. So Olga, maybe you can start us out a little bit. But when we talk about 5 nines of streaming sports at scale, delivering really great live sports experiences, how does device fragmentation complicate our ability to do that?
Wow, where do I even start? I mean, at some point we were trying to help out a client in Eastern Europe who was delivering to televisions that were 10 years, 12 years old. And this was a couple of years ago. And we were trying to figure out how to deliver content to a television that was supporting like the very first version of Silverlight and has never been updated since. And I think when you are delivering, again, large, especially global, because if you're doing, we'll pick on Super Bowl, mostly, I mean, parts of the world watch it, but it's mostly a US thing, but you kind of sort of have a better idea of what the device landscape looks like. But if, like Christy mentioned, Olympics or, like European football, like FIFA or everything else worldwide, you might be delivering content to a whole zoo of devices. And I'm not the best person to tell you what kind of codec and file formats and everything that those devices support. But that, as I think, is one of the things that we have to absolutely think about, because we constantly get issues of, well, we need to test this specific device with this specific encryption, and does it actually work? Because, the license gets delivered, the content is there, but just nothing plays. And yet again, if you're dealing with your own country and you have somewhat of a closed ecosystem, you know what you're looking at. But if you're doing world events to Malaysia and US and Canada and Brazil and Chile, what is your device ecosystem and what are you trying to hit? I think that is like one of the scarier questions to answer too.
One of the ways that YouTube deals with the scale is the scale challenge and the device fragmentation challenge is, taking the sort of approach of we want the same experience across devices everywhere. And it's really hard to achieve when you have to develop for all these platforms, especially the esoteric platforms that, Olga mentioned. DRM, DRM encryption aside, just getting the same user experience is a massive challenge. And the way that we sort of fundamentally have been thinking about it is porting a lot of the client side logic, everything from ABR to multi-viewing experiences to the edge, really generating these either in our core compute or at the edge, wherever we can, rendering rendering these sort of multi-view experiences or server-side ABR such that we can, deliver the same experience across devices globally. And it works. It works really well, but it provides a different type of challenge, right? When you're adding that, it adds to the scale problem on the server side. It does help with the development resources of not having to have, massive development teams per client platform. But the server side scaling aspect of it and being able to have those really rich experiences you can provide when you have a lot of that logic client side is now the challenge we're facing. Not to mention there's actually more bandwidth and more network requests going out now, so it exacerbates the kind of scale challenge. But it is a way to offer the kind of seamless or standard user experience across these older legacy or esoteric devices.
Oh, so Sean, you're saying that the old-timey solution of this website is optimized for Google Chrome. Please switch to Google Chrome to watch this video. It's no longer an option. Is that what you're saying?
I don't think users appreciate it.
Although with his new job, he might be more inclined to support the Chrome.
Yeah, exactly.
The reality is device diversity becomes an economic decision for content distributors. Like it or not, it gets incrementally harder to address the edges of the device landscape. LG and Samsung TVs older than 2018, you have to look at, that's going to raise maybe by a third your engineering cost to support it, right? And is that fraction of your audience worth the revenue you're getting from supporting them? And it's all, I meet with many distributors facing exactly the same decision. And they're like, yes, we make more money and it's worth it. But at some point they cross that line and that's when you release device support, right? It's not that they don't want to support the users. It becomes economically unsustainable for them to keep doing that. And platforms like say HTML5 MSE-based playback, it gives you a very flexible environment to reach a lot of players if you can assure that your device actually supports it. So you can counter the device diversity with common application frameworks like that. But the challenge is the older TVs don't support that any better than they do HLS or Dash without DRM. So you're always stuck deciding where you want to sit on the curve of device support.
And as ad supported become, whether it's free DAI, fast, or your standard SVOD with DAI, it becomes even more challenging because as ad revenue becomes more and more prominent, hitting those older devices is more and more difficult to justify. But you want as many eyeballs as you can, but the ad ecosystem doesn't necessarily play nicely with the older devices. So there are business decisions that are made to sunset legacy platforms. Finding out what that number is the challenge, and it's a negotiation with the business.
Christy, thoughts from Swerve?
Well, I think, yeah, I always try to put the consumer at the center of our decision making, and it is truly impossible to test, as Olga pointed out, for every device, for every interface scenario that the consumers are facing right now. And I think that is a massive, massive challenge for the streaming industry in general, not just sports, but for news and entertainment. When you're setting up a testing environment, and Sean mentioned this earlier too, you cannot possibly set up a testing environment that can test for all the different, even entry interfaces that consumers are facing. Tom brought up authentication. It looks different for every provider, and so it's just a real challenge. And I think the important thing is really to put the consumer at the center, because ultimately that will drive your business. And yeah, we do have to sometimes make decisions to not support older devices and smaller subsets of users, but that benefits the greater pool of users.
And Will brought up interesting. So the common framework, right, with MSEs, and that was brought up when I was in FOMS last year, right before DMUX. We talked about this, and it came out, ended up turning into a project at the SVTA, which is how can you know what capabilities a specific device supports And I got talking with Pankaj over at Disney, and he was like, we actually have a physical warehouse with TV sets in it that we go to make sure it can display the content the way we want it displayed. And that just seems crazy to me. So I think the industry pushing forward on these common frameworks, like Yashima with MSE on devices like CTVs is the way, hopefully, that we can go to get scale and get around some issues. But it still doesn't solve that problem of security, right? So some devices just aren't secure enough to display some of this premium content, and you just have to maybe just say deprecate it. So anyway, so that's very complex and challenging, but that leads us into this other thing about delivering the content to these devices. And protocol selection obviously is huge. And Will, this one is just strictly pointed right at you because you do so much work in the industry around protocols. Are there any upcoming protocols? Like, does protocol selection affect scalability? Yeah. Like, what's going on?
So clearly it's the bridge, but protocol is an overloaded word. The people use it to describe the streaming protocol, HLS or Dash or WebRTC, for example, and they use it to describe the transport protocol, which might be HTTP1, HTTP2, HTTP3. So those are all protocols. I can address them. The majority of your scaled media, your high scale events, everything we've spoken about is using adaptive segmented media, HLS and Dash, right? And those two formats have been around for a long time now. Both have low latency variants, standardized about 4 years ago, that we're seeing very little usage of. I was a big proponent. I thought latency would just drop down, but today 7 seconds is considered low latency, and most people are at 15 or higher, right? And they do that because it's more stable. It's a risk. As your latency reduces, your buffer risk increases. Your buffer is your safety margin for any sort of perturbation in your delivery. So HLS and Dash have to a large degree stabilized now. And in fact, there's a lot of work being done at CTA Wave to harmonize the two formats so that you can produce content that you can deliver both in terms of the content and in the features it supports, like captioning and ad insertion, deliver a consistent experience across those two formats. So we're seeing a lot of interop work being done there and a lot of outcome achieved. Your end consumer doesn't care what format you use to get them their rectangle of video, right? In terms of the HTTP protocol, everyone thought HTTP3 might be the magic answer to solving things. It's not a magic answer. It's an improvement under certain conditions, but simply applying HTTP3 to HLS and Dash is not going to significantly reduce your rebuffering on average across most networks, especially in the Western world where RTTs are low and packet loss is low. In terms of new protocols, I'm working a lot on media over quick. I think it's an interesting move to bring the very low latency, I'm talking 300-400 milliseconds, that you get with WebRTC, but then to decouple that from the codec and the transport there and give you a separate transport protocol that can move essentially binary payloads, of which media is one. So it tries to combine the very high scale that we get with HLS and Dash through cacheability with the low latency that we can get with WebRTC. So this is under standardization for 2 years now. It's still active. There's not commercial products. There's nothing to buy from anybody yet. But in terms of future-facing technology that can impact live sports, I think it's a serious contender, to put it in the fighting category, which is probably Christy's world more than mine. But it's certainly coming. It will come out swinging soon, and I think it's something to look at when it does.
Anybody want to add to that?
Oh, I have a question. Actually, I think it's a good learning opportunity for folks. So,
Yes.
like, how do you think about these protocols in the context of the device fragmentation issue? Only specifically because, we would assume if we start delivering H2 or H3 and a device supports it, it's just going to perform better than the previous protocol, or one that's maybe less. Just a previous protocol. But what we actually saw in kind of a deep dive analysis of Paramount was there were select devices that actually perform better with H1 as opposed to H2, and we never quite understood that. And so, like, when we're thinking about media over quick, or we're thinking about H3, we're thinking about these next gen protocols, should we be thinking that they should as long as a device supports it, just blanketly turn it on? Or should we be more specific about device targeting?
Clearly not. You should never blanket turn anything on in live streaming. Device selection. So you got a matrix, right? You got devices and you got protocols coming down, and there's an optimal grid. You can only support so many permutations of protocol, and it's like streaming format plus transport protocol. So you're going to constrain that to a few. The challenge with the transport protocols is you're addressing edge cases. H2 is going to be better than H1 under certain conditions. H3 will be better than both of those under other conditions. H3 uses QUIC. QUIC is more CPU intensive today because it's not being implemented fully in hardware. So we have a higher cost to deliver it, even if we get a transport level gain out of it. So I'm still up to, I think the challenge, as Sean mentioned, you have to be clever in how you allocate to these protocols, and it's not one protocol for everyone. In fact, I don't want to even mention AI word. I'll call it machine learning because that's far closer to what it is. You want to be clever. You got a matrix of inputs, congestion, RTT network, historical performance on AS, and then you might choose to deploy a protocol plus a streaming format plus a player type to this particular session, because you figured out that has the highest likelihood of delivering the best quality for the end user.
And that's the exact approach, we tried to take. It was finding those corner cases. And when that's what brings you from 4 nines to 5 nines, when you can, actually do that. The challenge is getting all the data in one place and having the time and the sort of effort to derive those insights. But
live data, metrics, and analytics are becoming a cornerstone of successful live events, right? Because you need the metrics to optimize the permutations that I just mentioned.
Well, it's interesting that conversation right there brings up this complexity of actually delivering live events, whether they're at scale or not, just delivering them because of the lack of interoperability within the streaming video tech stack that broadcast doesn't suffer from, right? Broadcast has QAM. Okay, we're done. We can get this out to you. We're all good. Streaming is much harder because you have all these permutations. So now you have this really complex workflow delivery. Like, how do we? It's this and this device and this over here and this. And Will, back to what you said earlier, it's about the economics. When does it become non-economical to support one of those permutations? And so I want to shift gears just a little bit, and I want to get Tom to answer this one. And then Will jump into this, and Sean and Christy and Olga, please pile onto this, because this is about something we've talked about in this industry for 30 years. Multicast. It's the nasty M word, right? So, would multicast enable live sports streaming to reach broadcast-like scalability? How would it affect this 5 nines challenge that we're talking about? And, Tom, kick us off, and then everybody jump in.
I think the short answer is probably yes to that question. Part of it, again, I think this goes back to economics and what you're willing to invest in your technology for, what the return on investment is. So there are some, there are global events, and again, I'll throw Tata into this. We use our fiber network when we do anything. The Tata global fiber network, and obviously with the Switch fiber network in the US is pretty extensive. We carry about 30% of the world's internet on our network. So we can move, we can move lots of feeds around the world without having to, go off of our network. So that includes managing, and again, managing a multicast is going to be at the heart of this as well. So, there's a lot here that you'd have to unwrap and make sure you could dedicate the resources to it to really get all of the advantages of what a multicast can do for you.
So yeah,
Buddy?
everyone thinks multicast is a magic panacea because you see it work for television and you think, well, surely that will work for the web, right? That's how you deliver the same content to everyone at the same time. But it's different for television, right? You have an assured quality of service, which is your broadcast in the air signal. So you're not having to adapt anything. And every receiver in the United States is ATSC1 or ATSC3 compliant. So you have one device type essentially that you're serving to. So yes, it works for that, but multicast is a terrible solution for everything that's not a live sporting event, which is all the movies we like to watch, different movies on a Tuesday. So ideally, yes, a multicast-like solution would be key during a peak event, but then it's not optimal at any other time. So do you build two networks, right? And you only use one for 4 hours during a live event and the other one? Mostly the economics suggest that you should build one network that can try to do both. At Akamai, we've had multicast product now for 8 years. I don't think most people even know it exists. Come and buy it from us. We would love you to. We support it. It's used mostly in Central and South America. Multicast requires that you can multicast into the networks. The network you're distributing through has to be multicast compliant, which is not true of many of the networks today. And it even converts from adaptive media into multicast and back again at the other end, which is the other problem because your phone is not receiving the multicast signal. So you have this endpoint problem and termination problem of multicast. So terrestrial multicast is a challenge. There's cellular multicast, LTE-B, eMBMS. That has been around for 4G. It's improved for 5G. I know Telstra did deployments down in Australia, but we should question, that's closer. It's IP-based to begin with. And even that is not used at scale for live events today. There's not a lot of deployments. That's closer. ATSC3 offers file delivery. There's another opportunity there. I know they're trying to develop a consortium to make it easy to sideband deliver files for large sporting events. So there are efforts with multicast. And if you look at Mock and you squint your eyes and you turn the cache down to 0, it has the characteristics of a multicast network too, if you design it like that. So we have multicast opportunities, but they don't deliver the immediate benefits that I think many people do and that they associate historically with television.
Well, and I'm going to put a security hat on this and ask you if you can secure a multicast stream. And the answer is not really, to the extent that, live sporting events would be like, sure, let's be around this. You can't, but let's stream it anyway. With all the cost of all the sports rights for all the live events, and think about how much a Super Bowl commercial is. If we had to deliver it in an unsecure fashion that's easily piratable, I don't know if we could actually run it as a business overall, regardless of what the technology can do or not. Would the business side allow it to even happen?
Two things come to mind here. One, when we compare traditional broadcast or anything over the air, things are more standardized, like Will said. Every receiver is the same, it's standard. But the second aspect of it is we don't get the telemetry back from the devices to know how it actually looks on the screen and what the end user experience is. So we assume it's better, and it probably is given the standardization. But in the streaming world, we can see every rebuffer session, right? So we're holding ourselves to a higher standard in that regard. But the second aspect of it, when it comes to multicast, this has come up a few times. There's always going to be the next sort of catalyst for, this will require multicast to scale. Maybe it's the Super Bowl or the Jake Paul fight. Or one thing that came up a couple years ago that actually seriously had us considering multicast was the advent of proxy services like Apple Private Relay. We thought that these would really degrade the quality of the streams, and the reality of it is they didn't. At the scale at which we were growing, it just hasn't been necessary to kind of really take that brute force approach to changing the streaming workflow from a unicast solution to multicast. I think media over quick makes a lot more sense personally, but yeah, I haven't seen the need for it yet in any of our applications.
All right.
Router traffic blocking some of the multicast packets is is also a big concern.
Yeah, there's obviously lots of challenges here with all sorts of technologies that we could try, not try under certain conditions. So it's really interesting to hear you all talk about some of these. With that said, we've got about 15 minutes left. We've got a couple of questions, and then I've got one last question about sort of the concept of 5 nines. So let's look at our audience questions first. And the first question is from Mike. And he's really asking about why the panelists have not fixed the last mile problem. So AS and ISP limitations that have been around for, in his a couple of decades. Yeah, been a long time. So what are your thoughts on that? What's the issue with last mile? Does that create really big problems with live streaming sports at scales for 5 nines?
Well, maybe because none of us own the last mile. Like, so we can't fix it, right? It's the ISP is the last mile is critical to delivery, and everyone, Netflix, Akamai, YouTube, are doing their best to make the last mile as short as possible, right? We put servers right there in the ISP so that you don't have to go through peering points, but that ISP is still solely responsible for moving traffic from your server to the end device. So it would be great. And it's not like they're not trying either. They also have fixed equipment. They have certain revenue cap that they have to meet. And they have a high installation cost. If they're cable, it's much harder to lay trench and improve things. So I think the biggest change I see coming in last mile, which is interesting, is low Earth orbit satellites, Starlink in particular. Starlink is now on Akamai, and this is true of other CDNs. It's the 17th largest AS that we deliver traffic to in the whole world. That's a big fraction of traffic, considering it didn't exist 2 years ago. And Starlink is interesting in that it delivers a ubiquitous service globally, or not exactly ubiquitous, right? But it's fundamentally better. I'm from Zimbabwe, and Starlink launched in Zimbabwe, and I think Cloudflare introduced very interesting stats, and Netflix also did a study where 300% ramp up in traffic. So Starlink brings with it a new audience. For everyone here who wants to distribute content, you can now reach people you could never reach before through terrestrial or over-the-air networks. So I think in terms of last mile innovation, that's a fantastic innovation, one that didn't exist 10 years ago, and one that we need to adapt our delivery systems to. And the Netflix paper, if you read it, goes into some details, but there are workarounds, and you can deliver a decent quality of QoE, even to Zimbabwe and Malawi, over low Earth orbit satellite.
Actually, that's an interesting point, because when I was in Kenya for the past week, they brought up Starlink to me when I told them what I did, and I said, do you use it quite a bit? And they said, yeah, it basically replaces the need for 5G, if you're going to put up 5G towers every 5 miles or whatever. It replaced the need for hardware, which, as you know, Will, since you're from Zimbabwe, that mobile cellular devices have far outweighed putting fiber in the ground. The other thing is, I did a lot of work, or I was starting to do a lot of work with AWS and Project Kuiper, which is their expanded version of low Earth orbit satellites. And we talked about having a 7-inch receiver, a 10-inch receiver, and a 12-inch receiver, so that you could, their goal is to have a school kid carry something in their backpack, take it to school or take it somewhere, and be able to pop it out and use it to get internet on their computer. So I agree. I think the last mile problems that everybody's been trying to look at in the same exact way, I think low Earth orbit satellites are something that we should all, take a look at and see about embracing.
Right. The network Starlinks and Viasats, that traffic is growing. So I'm surprised it's already 17th largest, but it's not surprising that it's growing. And there are unique challenges, at least. So if you look at it from a content provider standpoint that might have multiple CDN vendors, one thing we tried to do at Paramount was route users to the most optimal CDN. sort of aggregated at some dimensionality. And for us, it was the geo ASN level. And that became very difficult. And we got a lot of CDN flapping when it came to users on Starlink and Viasat. And it was because of just the way that, a performance was assessed. And I don't really know what's unique about the networks in that regard, but it's something that we had to explore. We have to explore more, because our standard sort of logic of, measure performance of a given user in a given geo on a given ASN just didn't work. We would be bouncing between CDNs when it came to Starlink and Viasat. And then thinking about it from the CDN perspective, it's probably even more of a challenge.
So thank you for answering the question, everybody. I've got one here as well. And Christy, maybe you can answer this for us first. But it's about the scale of operations. So this is a really interesting question. So Dom Robinson is basically asking, how do you deal with a situation where you've got 7 or 8 people who are, overseeing multiple simultaneous live events at the same time? And maybe they're not scaled to the tens of millions, but they're scaled to the tens of thousands. His question really is, how can you become aware, and what do you need to become aware of the problems as they happen and be able to react to them in real time, which is what you need to do, obviously, for a live event?
Well, in my experience, I think it pays to invest in an experienced team. And the good news about that is that we've all been doing this long enough now in the industry that there are people you can hire who are adept at managing the unknown, multiple live events at the same time. They might not come from the sports space. They might come from the news space. I think one thing we think about in the sports industry as well, if you have experience producing sports, whether that's broadcast or cable, then you should be good at streaming sports. That's not necessarily the case. I would recommend operationally hiring people who are adept at streaming and start there. And then we can grow to stream multiple live events at the same time. But oftentimes, I particularly in news, you have multiple breaking events at the same time that must be managed. And those production teams have a real skill at managing the unknown and unpredictable.
Anybody else thoughts? I know, Sean, obviously this is near and dear to you, and Will, you've probably been in the trenches a fair number of times.
Yeah, so yes, I want to make sure that I answer the question, and I may have gotten distracted with some questions that came in the chats from Dom, but I think that it dovetails into he was asking about scaling, sort of broadcast operations or operations and eyes on glass, that sort of bit of it, as well as kind of the brute force, challenge of really needing so many, I guess, mes copies of various streams in order to offer that seamless experience. And that is a really big challenge that I don't think has been solved. I think that solutions, one thing we're trying to do is say, okay, if we're acquiring, one event, we want 4 mes copies, 4 high quality copies of that event, pre-transcoded, ingested direct fiber to our ingestion network. And that's asking a lot of the broadcasters, and it's really unnecessary. We shouldn't need 4 redundant copies, in my opinion. 1 or 2 with the right resiliency should be our goal. And so we're trying to figure out what is that interesting software, and obviously SRT helps. Not need the when it comes to not needing to build direct cross connects and fiber networks, just using internet topology. But the aspect of what can we do at the ingestion layer to find leading indicators of quality degradation, where you can just flip between 1 or 2 copies very quickly and not require 4 redundant copies, is something that we really don't have a solution for today. That's driving a lot of development efforts. So I was slightly related to the previous question, but I got into the weeds with what Dom was asking.
No, but it's important, right? It goes back to that original sort of this whole discussion that there is a lot of complexity at every part of the process of delivering live sports at scale with, 5 nines, right? So that kind of leads us into this last question. And, maybe, Tom, maybe you can start us out first, but is 5 nines, is that the right target we should be aiming for? Is there something else we should be aiming for?
It's I thought about this a lot and I changed my answer a couple of times because I think at the end of the day, you got to just work backwards from what your goal is. Like what's your business goal when it comes to whatever it is that you're streaming? And 5 nines, there's stuff that's good enough and there's stuff that really needs to be 5 nines. So depending upon what your business model looks like and what 5 nines will either do to help your business model. For example, sports betting. I think I brought this up in an email to the group, but if you're doing sports betting, you're marrying data to video and it's all got to get there at the same time because the minute that the video is behind the data, you're kind of screwing up your wagering, right? The data comes first, the video comes next. There's somebody I worked with a couple of years ago, and he talked about deterministic latency as opposed to just 5 nines. So if you say that you're going to deliver a feed of a live sports event and there's wagering involved, and you're going to drop it at 300 milliseconds from venue to edge before it gets to the consumer. And it's all the packets are going to be there. All the data is going to be married to the whatever the time code on the video is. Then that's great. That I think addresses a large part of the issue. So 5 nines, is sort of what broadcast television looks to. You drop a packet and they bill you back $1.5 million, or whatever. But I think there's other things that are involved here that, in addition to just 5 nines, that play into the commercial aspect of streaming.
Yeah, I want to make the point that 5 nines is not that high. If a CDN was 5 nines reliable for 4.5 minutes a month, we could serve absolutely no traffic and still be within an SLA. Or Olga could serve 1 million license requests and not return a license for 1,000 of them. That's 5 nines reliable, right? It's not actually that high. And the challenge comes in increasing that reliability becomes expensive for individual components. So in the mathematics reliability, it's cheaper to get 5 nines reliability. I can get that from one component or two components that are 99.7% reliable, or three components that are 96% point something reliable, right? And they're much cheaper components. So what we want to do is cheaper, less reliable components orchestrated to create a system level reliability that's high, which in turn means that the science of detecting failures, reacting to them, and ensuring that I fail down, fail over across these redundant components, that becomes the science of high capacity live streaming.
Exactly.
Fantastic.
Don't throw more in the case of the ingestion. It's the case I'm trying to make is to not throw more streams and more infrastructure at the problem to get that reliability, but catch trends quickly and automate your way around quality degradation. It'll be much cheaper, but there's a lot of work that needs to be done in that space.
Absolutely.
See,
well,
and
listen. Oh, sorry.
But at the end of the day, I like the comment that Christy made earlier today it's all about the user experience, right? So at the end of the day, what can our users tolerate and what they can't? And I think that also varies by generation a bit. And when we're all spoiled, then it has to be here now all the time. Why is it not loading? But just like Tom mentioned, if you're delivering, and I'm looking at it from, latency perspective, if you're delivering content to betting, it's one specific user experience. And if you're watching a game or something else, it's a different user experience. And I think whatever it is, at 5 nines, 6 nines, or 2 nines, whatever it is that we need to deliver for the user to enjoy the service we're offering, I think that's what we should be shooting for.
And that is a great way to round this panel up. So listen, we're at time. This was fantastic. Great conversation. You basically pointed out that this is really complicated, really complex, and we got to figure out how to solve it. I'm going to challenge that even more, that in 2027, NASA's going to be delivering from the moon, live streaming from the moon. That's a global event. That is going to probably be hundreds of millions of concurrents. It is going to be the most massive live streaming event we've ever seen. We've got 2 years in this industry to figure this stuff out. So with that said, thank you so much, everyone, for your contributions. It's fantastic. Thank you, audience, for staying with us. And listen, hand it back over to Steve. It's been a great panel. Thanks, everybody.
Thank you.
Thanks, JT. Thanks, everyone. I'd say that's a pretty daunting challenge you just left us with there, JT. But yeah, thanks you all. Thank you all for the great conversation, and this has been terrific. Before we go, our walk-up music that we heard coming in was, of course, "Only the Strong Survive" by the late great Jerry Butler, and the winner is Paul Faleo. Correctly identified the track and the artist. And once again, thank you all again, and please join us back here at 1 p.m. Eastern Time, 10 a.m. Pacific Time, for how to leverage AI for captioning and localization.
Thank you. Bye-bye.